In the vast expanse of the cosmos, our journey begins with a profound question that echoes through the ages. Could life, the intricate dance of molecules and energy, be a phenomenon that transcends the boundaries of our planet? As we set sail on the Panspermia Odyssey, we step into the realm of speculative science, where the possibility of life's origins takes on an interstellar perspective. The cosmic cradle, a term that embodies the essence of our quest, invites us to ponder whether life's seeds might have been scattered far beyond our terrestrial abode. Panspermia Odyssey refers to a fascinating hypothesis and speculative concept in the field of astrobiology and astronomy. It proposes the idea that life, in the form of microorganisms or even more complex organisms, could be spread throughout the universe through various mechanisms, allowing the potential for life to arise on different planets or celestial bodies. This concept challenges traditional views on the origin of life being confined solely to Earth, and suggests that life might have a broader cosmic origin. There are several different hypotheses and mechanisms proposed within the framework of panspermia that attempt to explain how life could be transported across space. These mechanisms can be broadly categorized into two main types: interstellar panspermia and interplanetary panspermia. Interstellar panspermia proposes that life could travel between star systems. Microorganisms could survive space conditions and be carried by radiation pressure or solar wind to other star systems. Alternatively, life might hitch a ride on planetesimals like asteroids or comets, which could collide with other planets and transfer life. Interplanetary panspermia says that, within a single star system, life could move between planets or moons. Microbes could be carried by debris from meteor impacts, lithopanspermia, or lifted into space by natural events, potentially landing on other planets and surviving. One of the key arguments for panspermia is the complexity of organic molecules found on meteorites and in space. These molecules are considered precursors to life and have been detected in comets and interstellar dust. The presence of these molecules in space suggests that the basic building blocks for life might be widespread throughout the universe. The early Earth was a hostile environment, characterized by high levels of volcanic activity, frequent impacts by celestial bodies, and a lack of a stable atmosphere. The presence of intense ultraviolet, UV radiation, cosmic rays, and extreme temperature fluctuations made it challenging for life to emerge and thrive. Panspermia proposes that life might have originated in a more benign environment elsewhere in the universe, such as on a planet with a stable atmosphere and protective magnetic field. In such environments, the necessary building blocks of life could have more readily formed, and complex organic molecules could have evolved without being disrupted by extreme conditions. According to the panspermia hypothesis, microorganisms or organic molecules could have been ejected from their home planets due to impacts by asteroids, comets, or other celestial bodies. These particles might have been encased in rocks or meteorites, which would provide some degree of protection against radiation and harsh space conditions during their journey through space. While the survival of microorganisms during interplanetary travel is a subject of debate, proponents of panspermia suggest that some hardy microorganisms could potentially survive the journey due to their ability to enter a dormant or spore-like state. This state could provide protection against dehydration, radiation, and extreme temperature variations. Upon reaching Earth, the microorganisms or organic molecules transported via panspermia might have found more suitable conditions for life's development. As the Earth's environment evolved and stabilized over time, these transported entities could have contributed to the emergence and diversification of life. Some microorganisms on Earth are incredibly resilient and capable of surviving extreme conditions, such as high radiation, extreme temperatures, and the vacuum of space. This has led to the speculation that similar microorganisms might be able to survive interplanetary travel. There are hardy microorganisms, often called extremophiles, who are microorganisms that have adapted to survive and flourish in environments that are considered extreme by conventional standards. These environments exhibit extreme conditions such as high temperatures, extreme acidity or alkalinity, high radiation levels, intense pressure, and other challenging factors. The survival of these microorganisms in such conditions provides valuable insights into the potential resilience of life in extreme environments, and it even relates to the concept of panspermia. While there is currently no definitive evidence supporting this hypothesis, there are several events and mechanisms that could potentially bring life or its building blocks to Earth from other locations in the universe. Asteroid or meteorite impacts on other celestial bodies could eject material containing microorganisms or organic molecules into space. Similarly, cometary impacts might release frozen organic compounds that could reach Earth. Microscopic particles like cosmic dust could carry life's building blocks through space, and dense interstellar clouds are thought to potentially harbor these crucial compounds. Hypervelocity stars, if carrying planets with life, could traverse space and bring life to other star systems. Even planetary collisions might eject material into space that could eventually reach Earth. While these ideas offer intriguing possibilities for the transfer of life, it's essential to note that they remain speculative, and concrete evidence is still lacking to confirm the occurrence of such events. The panspermia hypothesis, while intriguing, also raises a series of unanswered questions that challenge its plausibility and necessitate further investigation. One of the central questions revolves around the survival of microorganisms during the journey through space. The extreme conditions of outer space, including vacuum, radiation, and temperature fluctuations, could pose significant challenges to the viability of any life forms making such a journey. While some hardy microorganisms have shown resilience in terrestrial extreme environments, the leap to surviving the rigors of space remains speculative. The origin of life itself is a complex enigma that the panspermia hypothesis does not fully address. While it offers a potential solution to the challenge of life's emergence on Earth, it merely transfers the question of life's origin to another location. How did life initially arise on the source planet or celestial body, and what mechanisms allowed it to endure and be ejected into space? These questions extend beyond the boundaries of panspermia itself and delve into the broader realms of abiogenesis and the conditions necessary for life to begin. Moreover, the mechanisms by which microorganisms or organic molecules could be transported across vast cosmic distances remain uncertain. The panspermia hypothesis suggests that these entities could be carried on meteorites or other space debris, but the likelihood of such transport without severe damage or destruction poses significant challenges. Additionally, the specificity of the conditions required for a successful landing and establishment on a new planet raises questions about the probability of successful panspermia events. Thank you for exploring the fascinating world of astrobiology and the panspermia hypothesis with us. If you're hungry for more intriguing content about space, the origins of life, and the mysteries of the universe, make sure to subscribe to Astronovium. Stay curious, keep exploring, and join us on a journey through the cosmos. Don't forget to hit that subscribe button for more captivating insights into the wonders of the universe.